a short vlog video about the update on the bass boost amplifier. This is the power supply that I made. The circuit was in an earlier video. It is exactly the same, like I have drawn the schematic in that earlier video, and I will give the link. So more or less nothing has changed. The Darlington driver, that is the hum suppressor, is here. The 2N3055 is here at the underside. The driver of the 2N3055 is here. It doesn't get very hot, the heatsink, that's very good. Here are two transformers that I have switched on their primary parallel, but on their secondary in series. And very important to tell, use in such a case two transformers that have the same properties in terms of wattage, say the power that they can send out. And here this transformer is approximately 8 watt and this one also. So you can connect the secondaries in series, and when you want to do that, very important is that the phase of the two secondary transistor windings must be okay. When the phase of these two transistor, I say again transistor, but I mean of course transformer windings, when the two secondary transformer windings are not connected properly together, you have a zero output voltage. And when they are properly connected together, you can add the voltage of both transformers. And both transformers in this case give approximately 12 volt out. This one is officially 18 volts out, and this one is officially 12 volts out, but of course, say, has everything to do with the open voltage and the voltage under a certain load. And then I mean a certain load on the secondary. All, say, the indications of these transformers are nominal. So when they say that this is a 12 volt, say a 12 watt transformer, it can give only that 12 watt out when on the secondary there is a load, a resistor or whatever that takes a certain current. Say 12 volt, 1 ampere is 12 watt. This is a kind of rule of thumb, but anyway. Again, the bass boost amplifier that I'm working on. Well, there are some things to tell. I burnt out the original transistor here, the first transistor in the schematic, and I have already made to the videos that I've uploaded to YouTube, that I have replaced that first transistor with a BD140 PNP silicon medium power transistor. Such a transistor is quite sturdy and cannot burn out easily. Furthermore, the whole circuit works properly. I've now connected an amperemeter so that we can see what happens when we send in to the amplifier a signal. Let's do that. So here we have a signal, and this is a sine wave signal, of course. It's on in the order of 3 kilocycles up to 15 kilocycles. Can change the frequency somewhat. This is the maximum frequency, by the way. Oh, you can hear it beep now. Say this is the maximum frequency at the moment. I don't want to connect my counter, but anyway, you can see that the circuit takes current, a certain current, but when you overdrive a audio amplifier, the waveform changes. Let me show that. So we have a heavy distortion, but this is a kind of, say, way to do a very heavy test on an audio amplifier. I see that my camera is flickering, so perhaps I have only 1 minute or 2 minutes and it will suddenly stop, but sorry for that. I will do my best. Here is the waveform again, proper waveform by the way. And let's go to a lower frequency, say to the lower frequency band of this amplifier. Well, now it's again overdriven in the frequency band of 39 Hz up to 200 Hz. Bring down the input signal somewhat, and then we have a good sine wave. And again, here you say can get a kind of indication of the power of such an amplifier. Here are 4 incandescent lamps of 21 watt at 12 volts in series, and they are also in series with this 4 ohm power resistor. I think it's a good test. The circuit takes 360 milliampere, so when we calculate that, the voltage is 35 volt multiplied by 360 milliampere, say 9 watt or so. Anyway, this amplifier can work on 40 volts, even 42 volts. We have here that hum suppressor, extreme hum suppressor, and you can surely see that there is absolutely no hum at the output of this amplifier. And well, that was more or less all to tell. Here we are on a higher frequency. Here we are on the highest frequency. Bring down the input level somewhat. You can see that the sine wave is very good in this range to 15 kilocycles. So these are more or less the most important things to tell in this update. Thanks for watching. I will surely publish the complete schematic with the bass boost audio filter at the input. Now there is no audio filter at the input, so I have to develop that again for this specific circuit, and also take in account, for instance, the effects of that first transistor. Made some ventilation holes, tested this audio amplifier, of course, at first. So here are ventilation holes with mesh. I'm now going to flip the amplifier over. Could be that I get a kind of shortcut in the wiring, but anyway, I want to show it. So here you see the mesh, so that we can get from the underside of this amplifier a draft. That's always very important when you want to cool audio amplifiers or whatever. There will be a hood positioned over this whole amplifier. There will be holes here in that hood so that we can get a kind of draft from the underside of the audio amplifier to the upper side, and then especially around the circuits that get warm. So that was more or less everything. Thanks for watching. Hope you liked it. And the waveform is quite good. Much more in the final videos, and perhaps I will also do then in that case more testing. Say on the sound character of this amplifier. Audio amplifiers have in general their own sound character.